Hey, John Gilroy here. In 1970, breaking news was the release of a relational database. Today, we will take a look at a modern way to look at understanding data. Hit the music, Manny. Welcome to the Federal Tech Podcast, the podcast that connects you to federal technology leaders. My name is John Gilroy, and I will be your moderator. Our guest today is John Bender, Regional Vice President for Federal Sales at a company called Neo4j. And if you're playing along at home, it's NEO, the numeral 4, then J.com. And we're going to talk about this fancy new way to connect the dots. So is that how we summarize this, John? How to connect the dots?
That works for me.
Yeah, good. Well, let me set the stage here. I had that silly open about 1970, and that's probably before John Bender was even born. But anyway, it's kind of a way that relational database exists, and it still exists to the day. And the problem is there's some limitations to that basic format. And so what we have now is we have an offering called Neo4j that helps with that. I'm kind of paint the picture. Why don't you paint the picture better for me there, Bender?
Sure. So, graph database, is a way to look at your data in a more probably natural way, or the way that, the human brain might look at information, right? So, you mentioned the relational databases. They have been around for a while. And when they were first designed, they're using tables and mapping tables to bring tables together. And then they're using joins to help drive the data together. And it's somewhat rigid. You have to know kind of what you want to do when you're designing those tables, right? Which is great. And a lot of the OLTP or transactional processing systems like GLs and orders to cash, those kind of systems are very rigid. So those they work very, very well. Where they tend to have issues is when you're trying to ask questions of the data that it's not prepared for, or you're going more than one relationship deep, right? It becomes more difficult for those databases to perform. Where a graph database looks at, instead of having just one key like a relational would, the graph looks at, we call our keys, we do all our facts, we call them nodes. We have the set of nodes, right? And we also have relationships that basically describe how the nodes are related to each other. And we look at both of those functions as searchable. They're equally important. So it's not just John Bender that's important. It's also John Bender has a Jeep. Right? And what is the relationship to that Jeep? Well, the relationship could be, John bought it in 2019. John bought it or it's black, right? There's all these different relationship or descriptors about that relationship between John and Jeep, right? So those relationships in the middle are highly, highly searchable and queryable. So the other thing, we do, or the graph does, and we have a property graph at Neo4j, we're one of the originators. We calculate those relationships when we're loading the data. So it's at build time. So what that means is, at runtime, they're available. Where a relational database will build those relationships at query time or, at runtime. So you're basically, with a relational database, you can ask the questions, is my data connected? And depending on the complexity of the question, it's hard to say how long that may take to come back to you. Whereas on a graph, you don't have to ask, is it connected? You're asking questions like, how is my data connected? So now once you start to understand the difference and the powerful difference in those questions, you can really start to ask really hard questions. So I was reading an article, over the weekend, talking, just thinking about some graph stuff, and someone had asked a question I thought was interesting. Someone was trying to understand for a toaster. A sales rep was basically saying, I want to understand when, was the toaster bought? Tell me about, was the buyer in Kansas? Did they have a criminal record? And did they use the coupon this week? Now, that kind of a question, unless the relational database knew exactly to put the data in a sequence to answer that, would bring a relational system. It would be very difficult for it to answer. The graph, that answer will come back in very, very like nanoseconds. Bam, it's over, because we can quickly traverse all the relationship pointers instantly. So now,
I learned
that unleashes people's.
I learned SQL years ago, and these silly words, hops and index. But you're not making beer with his hops and index, and so what happens is, you say, give me all the Benders in Illinois, and then you give me all the Gilroys in Illinois. But now I think this is a structural way to search. I mean, it doesn't have that penalty of reindexing. And if you have 100 records, who cares? What about 1 million? What about 20 million? All of a sudden, the reindexing means time. And you said quickly, I said, yeah, I remember those ops. That was painful.
We have a customer in the Army that actually, and they're working on it from a supply chain, right? Because as you know, the Army is very complex. They have some very complex toys, if you'll allow the term, right? And within that, there'll be a lot of parts and a lot of distribution channels to manage when they deploy. So you've got, not only do you have it back at the, the depots where the building's happening or repairs, you got it already forward deployed stuff. You have a long supply chain. You got suppliers all over there. This particular customer has over 8 billion nodes and over 22 billion relationships in their graph because it's so complex. One particular asset could have hundreds and hundreds of thousands of parts, right? And are those parts common? Are they specific? What happens if a supplier goes down? How do I redirect? How do I make sure? Because in the past, without that information, the Army was forced to buy in bulk, quarterly. They would buy lots and lots of parts, whether they needed them or not. They had a set buying and they would move them out. Now they can have multiple buys over the quarter based on what's needed, based on what they know about the asset in real time, based on the graph, right? So it makes it, so not only is it saving them time, it's saving them a lot of money and they're more efficient. So, I dare say their readiness posture is improved, which is, at the end of the day, that is the goal, right? It's to improve the overall readiness for our customers.
I noticed that your company does business with NASA. I know a little bit about satellites, and there's going to be 30,000 satellites in the next 5 years up there. I mean, what's a relational database going to do in trying to understanding the projection of all these satellites in this complex environment? And it's just, it gets to the point where, maybe these silos are fine, but there's limitations. There's just limitations to understanding in this massive data set that bad things can happen without understanding these complex relationships.
Yeah, well, and so yes, that's a great analogy, from a supply chain. Yeah, NASA. We also work with NASA on a different problem, right? And that's another type of problem for the graph is, they call it a lessons learned graph, right? So they've been documenting all their research since the 1950s. They got 20 plus million documents out there of, projects and everything included in a project. So NASA's been putting that information in the graph because what they've come to realize is they've been making the same mistakes that someone made 20 years ago, right? So, and a lot of this happened when the shuttle, we had the shuttle disaster, the tragedy, and because of some of the heating shields, right? And they basically looked at it and said, could we have, prevented this by having better information from past research, from past projects? So they started putting this together. Now, they've saved, I think it was, they got to Mars 2 years earlier and saved millions by using our graph to do this kind of stuff, right? It's not anything that they were just using the data they had. We're just making it infinitely more, usable and relatable, because of the nature of the graph. And now I can see the relationships between projects. I can see it could be just, it could be as easy as who else has used heat shields and what was their results. What did they do? They wouldn't have known. That would have been so hard to find. Well, now that, they put it in the graph and, through vector and what have you, it comes up. It's like they're now using this to help prevent and shorten time to value, if you will.
So, John Bender, my question is, government got silos. We know that. Does this mean you need to wipe out all silos, or I guess this isn't for? I mean, there's specific use cases where your technology would apply, and some use cases where it might not apply, huh?
I will not say we're a cure-all. No, that is probably that would be arrogant and sophomoric of me. But you're right. There are certain areas when you're starting to look at data and you're starting to say, how can it, because, the data has been increasing in our customers exponentially. They're not throwing it away, right? Because it might be valuable, but they're not 100% sure. So they're not throwing anything away. So they have a lot of information in these data lakes out there and these data warehouses. And, the lakes are just, no pun intended, swimming with data. You can start to put the graph on there and start to bring them forward and look at the relationships and start to find relationships in their data. Right? We have some organizations that are simply using us to understand what they've got. Right? We have some that are, doing it more on looking at, people and actors and personnel and trying to, help understand events. We have some that are using it for cybersecurity. So, think of your example on the NASA and all the parts. Well, that's no different than a network, right? Because at the end of the day, the graph is a mathematical graph representation of, it's kind of a network. A lot of people think of networks with people, but why not switches and routers and settings and this and that, right? So you create a digital twin of a network, and we've got that going on with a couple of customers. So they're looking at this thing and saying, I have my digital twin where I can do stress testing on, right? And I have the real network where I'm watching intrusions in real time and trying to, how do I isolate it? What path are they, based on their attack, do I see where they might have a path to something that I could shut down? Or I could sit there and say, okay, on the digital twin, I could say, look at the different events we've had over time. What are the similarities? Where, in a graph, we'll call it a cluster. Where are the clusters of the relationship amongst the nodes, right? Do I see someone using the same URL 3 times, even though they're coming from different countries? Are they coming out of the same URL? It's those kind of things you start to look for, those patterns that show up all of a sudden. Right. Same thing in fraud. Right. So look, think about tax and fraud or grants fraud or anybody trying to do something they shouldn't. They tend to have patterns. The problem is it's so sparse, it's hard to see the patterns, but the graph brings them right forward. Right. So, that's why we, here at Neo4j, right, we are the leader in graph database and analytics. And that's what we do is we help our organizations find those hidden patterns and relationships across billions of data connections deeply, easily, and quickly. That's what we do.
You use the word cybersecurity event, and that's the term they use in the cybersecurity world for events. But you folks have an event coming up, and it's in October, and it's local.
Absolutely.
People can come on down and show up and throw tomatoes at you or demo something or see what. In fact, you're speaking twice at this event. So where can they come down and pick on you, John?
Absolutely. So October 9th, we have our Graph Summit Government. Right. It's an all-day event at the Spy Museum. So come on down. Yes, I will be there as a target if you bring a tomato. I'll try to dodge you, though. I'm telling you now.
And that's near the L'Enfant Plaza Metro, isn't it?
Exactly.
L'Enfant
Metro. Yeah. Easy to get to. And so it's a full day. And then at the end of the day, we're actually we're shutting down the museum as a whole. And we're giving people access to what's now is the 007. They have a big event there where they have all the different vehicles and stuff for the James Bond experience, they call it. So we're giving access to everybody for the James Bond experience and enjoy that. So, come on down, hear the VA. The VA will be there to talk about with IBM about what they're doing. Come on down and hear, what the Air Force is doing. We have quite a few of our customers talking here about how they're using the graph to better.
I think that many people like me, maybe they got interested in SQL and SQL databases and learned all those rules and special terms. And all of a sudden you get this John Bender guy talking about nodes. And I go, where did I was thinking nodes when I learned all that crazy stuff? And, so here's my database story. So I worked for a Microsoft partner for a while, and we go down to Microsoft Office in DC, and the database they used was an Oracle database.
Yeah.
and that's how I learned all my relational data through big stuff. But the stuff back then compared to the big stuff now, really? Petabytes? Is that we're talking now?
Absolutely we are. Internet of Things, everything's data now. Everything is a data element in one form or another now, and it's valuable. So it's exploding. And, if you don't know if it's useful or not, you're not throwing it away, right? Yeah. So they keep it all. And now that's where the graph can really help us say, let's see if it is valuable. Let's see if the relationships pan out.
I got to jump in here. There's people listening and they're walking their dog or they're working out, doing pull-ups or something. And so what I'm going to do is I'm going to put a link to this event in the show notes. And so if you're listening to this, you can go back to your computer and type in, or you can go to the website, and it's a tricky website. It's NEO and then the numeral 4j.com and sign up there. But it's a free event. I think this really just you may listen to something, and I've watched videos on this company. I've listened to previous interviews, and you're listening to John Bender now. But sometimes in order to connect the dots in the gray matter, you have to look at it and pull something aside and say, hey, Bender, look, this is our situation. It's a little different. And then you pull this guy aside and you go, okay, well, and he says, well, you know what? We did this at the Air Force. And and that's so much. And I read all the time, and I encourage people to read in videos, but sometimes it's face-to-face, and that's why I love these face-to-face events. Go down to the Spy Museum, have some fun, grab John and say, get over here, buddy. And here's my, or a friend, a friend has a problem. Have you heard that?
I'm good with that. And if I will dare this as well, folks, if you can't make the event and you're not sure, how to reach out, you can reach out to me directly. It's just john.bender@neo4j.com. Please feel free. I will respond as fast as I can and see how we can help. That's what we're here to do. Our goal here, our mission at Neo4j simply is to help the world make sense of data. That's it. So if you need help, give us a call.
Because you're throwing this vocabulary, the graph. It's like, well, you're using it very comfortably, and many people are going, what is the graph? You mean,
people think,
but
of an image, like a graphical
Yeah.
image kind of thing. And it's basic graph theory. It's a mathematical
Yeah.
graph theory representation of, as I said earlier, a network and how data connects. So one of the best ways to get people to think what a graph is, because I tell people now, I've been here 9 months or so, I see graphs everywhere now. It's like my sixth sense of graph, if you will, right? I see it everywhere. But I keep going back to, my visual is, and we've all seen the detective shows out there. We've watched at least one probably that has the cork board with somebody in the middle and a bunch of strings going everywhere on the cork board,
Yeah.
showing relationships, showing, hey, this person was here at this time, was there, they lived here, we've seen those with all those strings and the pins. By the way, that's a graph. That's a networking graph. You're showing
Yep.
how a central node networks and where they interact, and what else they're tied to. That's a graph. That's what we're talking about. And it's dynamic, right? It's, once you build the model and you load the data, it's right there. You can start to see, and you can start to see however many people, and you can start to see locations where some people get together. Yeah, it's a graph.
So I got to go back to my satellite folks. So I was interviewing this company, and they go, "What do you guys do?" "Oh, we troubleshoot satellites." "Oh, what do you fly up there with a wrench?" "No, what we do is we make a digital twin. We diagnose it here, and all of a sudden we can fix it through software over there." "Oh, I didn't know that." So I'm reading some stories about Neo4j going, you guys work digital twins too. A little different approach,
Yeah.
but the same idea is that, you may have something, let's say, rather sensitive, and you can make an image of it, troubleshoot it there, and then go back to the original. I mean,
Right.
this is then
Well,
you
my
can make a
networking
twin
example.
and then do an analysis based on your tools. It's a great idea.
So supply chains are valid or great use for that. So are the networking examples, because what you can
Yeah.
do is then you can do the network, and you can say, what if I took down this router or this switch? What happens? How does
Well, you
my
can't do it, John Bender, because you get in trouble, can you?
Yeah, I personally would, but if I do it in the digital twin hypothetically, right? But then you
Yeah,
can
yeah.
so you can understand, then they can actually use that to understand how does it reroute? What is this, because then you start using the algorithms, right? We actually have, a product that brings forth a lot of the data science algorithms, and you can start to then do, what's my shortest path from here now? Now that that's broke, what's my next shortest path? And you can start to look at different ways, and how does this heal, right? And you can, it's a great way to do that stress testing. Same thing on the supply chain. What if I lose a supplier? Or, let's say one of my suppliers is in a question of, manufacturing in a country that's having some stress, we'll call it right now. What happens if it gets disrupted? How do I reroute supply? How do I make sure that supply still gets to where it needs to go to make sure things are operational, right? And you can do that with the graph, right? The graph can say that, okay, now how do I get that over here? Where's it coming from next? You can ask those kind of, data scientific kind of queries into the graph. Absolutely. So,
Yeah, because
digital twinning can be very valuable.
yeah, if there's a scenario where, let's say, some assets are going to be deployed in a geographic area, maybe there's 3 or 4 approaches you want to test out, see what's the best, most efficient approach. So the people at Air Force Research Lab, AFRL, the big brainiacs out there, they have to play this what if scenario all the time.
Constant.
And very complicated what if scenario, and you better be right.
No, exactly. It's real, right? With the hypothetical situations that they're dealing with are real. They matter. So all that testing and type of stuff they do is so valuable, right? And the graph, if it's the right application, the digital twin off the graph would be amazingly helpful. It could really shorten the time for them to understand what's the best path.
Okay, let's look at the future.
Yeah.
Relational databases, silos, and this graphing technology. The graphing technology does seem to be a game changer. And the way I understand it is, a friend of mine went to buy a couch, and he put in a credit card, and his credit card agency is, "Hey, is this you buying this couch?" Because it was an anomaly. So we take that and multiply it by 1 million, then you get fraud and detection in Florida and find out all kinds of subtleties. So it's a new way to skin the cats, what it seems like.
Yeah, and we're not replacing relational database. Don't get me wrong. We're probably a better analytical view, but this is by no means are we looking to replace them, because there's a place and a great value to what the relational side does, and all the other non-SQLs. There's always a room for it, but the graph seems to be the best way to really get a handle on the hidden relationships in your data and things you didn't know existed, patterns that you didn't realize were there because they were so deep you didn't know. But the graph.
That's the title. That's the title of this interview: Hidden Relationships in Large Databases.
Yeah.
How? I was looking for a title and I couldn't. If I said graph, it would be misleading. But there, There's an analysis of what you folks do. It's good. Okay, crystal ball time. Give me a projection here next 4 or 5 years. More fraud, less fraud. Federal agencies going to start using this tool effectively. So what do you think is going to be happening next 5 years?
Completely, silly, wild guessing, I guess. I think, is fraud going to stop? No, it's not. If anything, I think the digital creativity that's out there is growing almost as fast, if not faster than the defenses are, right? So fraud's not stopping. There's people with time and intent. So it's going to happen. There will be better responses, though. I think what you're going to see is, the data, because you can't cause much fraud today without leaving a digital footprint of some sort. So that's capturable. And now that's now a relationship in the data, right? That's a pattern forming. We have, companies that are out there looking for, hey, someone's from 4 different countries trying to hack in through the same IP. It's like, that's a pattern that has to be flagged, right? Because that shouldn't be the case. Those are the things that before were hard to find. Now they surface very quickly. The graph can bring those forward very quickly. And then you can start to look for that pattern other areas of your network or in your what do you want to call it, your data. You can say, oh, that's happened before here. It's happened before here. So now you see clusters form, right? They didn't, that's somewhat new, I think, to be able to visually see that quickly and be able to, drill in on what's going on. Or the one I like is the absence of the cluster, where you expect to see something and you don't.
Yeah.
The ghost is also something to look into, right?
Yeah.
So those are the things that, there's much better tools coming forward. But no, I don't think fraud's going to go down. If anything, I think that it's going to continue to rise. I just think, tools, will continue to evolve to meet that, right? And, that's part of our journey here is to help our customers prepare and understand their data so they can manage their business as best they can. And some of that can be prevention. Sure.
So they can understand hidden relationships. Yeah, it's a good title. Again,
I'll put
a link in the show notes to the event that's coming up on October 9th, right downtown DC at the Metro stop there at the Spy Museum. Yeah, they moved. That's a new location for them. That's
it's a nice location. It's easy to get to, and I think it's going to be a great day. It's going to be pretty packed, but come on in. Look for me. Come say hi. If you heard us on John Gilroy's podcast here, come tell me. I'd love to hear that, so I can let John know that that.
Come on down.
Come on down, guys. We'd love to see you.
You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest John Bender, Regional Vice President for Federal Sales at a company called Neo4j.